Hello guys, this is Syed Mohammad Waqas. The topic which I'm going to discuss today is related to the drainage pipe sizing. So there I have prepared an Excel sheet. As you can see over here, there's a lot of tables which I'm going to use to calculate the drainage pipe size. And this is the drawing for the 9-story building. As you can see over here, it's given here, and we are going to calculate the pipe size for each branch. As you can see, the sections are given as A, B, C, D, E, F, G, H, I, and then stack J, and then run out K, and then we have run out again M. So this is the drawing which we are going to use and to calculate the drainage pipe size. Before starting calculation, I want to give one small message to you guys. If any one of you interested in PhD from Canada, then you guys should visit this channel, Vagabond TV. This channel is related to the PhD in Canada. There you find a lot of videos related to PhD in Canada. So this is really helpful for you guys if you are interested in PhD from Canada. So please subscribe this channel. So let's move back to our topic. So as you can see that there I have a drawing for 9-story buildings, and we have divided each branch. We have given the name of each branch as section A, B, C, D, E, F, G, H, and I. And this vertical stack is represented by J, this runout is represented by K, or offset is represented by K, and then again this vertical stack is represented by L, and this runout is represented by M. So as you can see that I have prepared this table. In branch A, how many fixture unit we have? As you can see over here, we have 70 fixture units. So you have to understand first what is the fixture unit. Fixture unit, if you remember that we have used the fixture unit in water supply pipe sizing. That time it was called water supply fixture unit, and here we are going to do for drainage system. That's why it's called drainage fixture units. So fixture unit basically depends on three factors, that is rate of discharge, time of operation, and frequency of use of fixture. So based on these factors, these tables prepared by ASPE, that is American Society of Plumbing Engineers, IPC International Plumbing Code, and UPC Uniform Plumbing Codes. So based on these factors, these tables developed by these IPC, UPC, and ASPE. So I took this table from ASPE, that is American Society of Plumbing Engineers. So based on this table, I'm gonna do the sizing of drainage piping. And as you can see that we have horizontal branch sections given as A, B, C, D is mentioned here in the Excel sheet, and we are going to calculate the pipe diameter. And then we have a vertical stack, that is J, and this vertical stack is represented by L, vertical stack J and L. And then we have offset or runout, that is represented by K and represented by M, K and M. And the list of the fixtures in each branch section is given over here. So for example, branch A, we have water closet, urinal, lavatory, kitchen sink, shower, domestic, bathtub, laundry, floor drain, and bidet. So according to that, we have write the fixture unit value from the table 6.2. So this is the table fixture unit per fixture or the group. So from this fixture we have taken value and we have given it over here. So for example, water closet, you can see the drainage fixture unit value is how much. You can see the water closet over here. So since we are using the valve operated water closet here, so we are going to use this value 6. So water closet drainage fixture unit value is 6. So you can write 6 here. So in the same way, you have to write the drainage fixture unit value for each and every fixture. And then number of fixtures given in branch A for water closet is 5. Urinal we have 2, and lavatory we have 2. So you need to multiply number of fixture with the individual fixture unit drainage fixture unit value, and you will get the total drainage fixture unit value for the water closet in the branch A. So total drainage fixture unit value given for branch A, it will be the sum of all these fixtures. It will be the sum of all these fixtures. So 30 for the water closet, 8 for the urinals. You need to sum up all of these drainage fixture unit value to get the total drainage fixture unit value in the branch A. So total drainage fixture unit value is the sum of all these, that is 70. Same way you have to write the drainage fixture unit values over here in this column for the branch B by seeing the which fixture unit is connected to the branch B. So you have to write the fixture unit values in here and then multiply with the number of fixture unit to get the total drainage fixture unit value. So this is how you have to do for all branches, that is A, B, C, D, E, F, G, H and I up till here. So first we are going to calculate the branch pipe size for branch A, B, C, D, E, F, G, H and I. And second we are going to calculate this stack pipe size represented by J, and then we calculate the pipe size for this offset runout K, and then again vertical stack pipe L, and then again this offset or runout M. So first we are going to calculate the pipe size for this branch A. Since we have 70 fixture unit connected to this branch A by using, and this table 6.4 we are going 6-4 is going to be used for fixture unit loads for sanitary branches. So we are going to use this table 6-4 to calculate this branch pipe size A for all of these branches. So we have 70 fixture unit over here. So as you can see, the total fixture unit we have 70 is in between 20 and 160 and in between 3 and 4 inches. So we will go for 160 on the higher side. So 160 on the higher side, so we'll get the pipe size is 4 inches. So we'll write 4 inch pipe size. And again branch B, that is 90 fixture units. 90 fixture units again come between same table 6-4 we'll use. It's in between 20 and 160, that is we'll go for the higher value, that is 4 inches. So in the same way you have to calculate for this 120 fixture unit branch C. 120 fixture unit is also between 20 and 160, so we'll go for the higher side, again 4 inches. So D has 90 fixture unit, we already calculated. For B it will be same as D, that is 4 inches. Now we'll calculate for the branch E, has 150 fixture unit load value. It's again less than 160, so we'll go for 160. It is in between 20 and we'll not go for 20, we'll go for 60. 160 and pipe size is 4 inches. And then you can see the branch F has 180 fixture units. So 180 fixture unit, it is in between 160 and 360. So we'll go for the higher value, 360. 360 we have 5 inch pipe diameter, so we're going to use 5 inch for section F. And then we have section branch G with 190 fixture unit. So in the same way you have to write for G, H and I. G is 190. 190 is also less than 360. We'll go for the higher value, that is 360 is 5 inches. And H is also 160. 160 is in bit 160 is here, 4 inches. And then I, you can see, is 200 fixture units. 200 fixture unit is in between 160 and 360, so 360, that is 5 inches. Now we have to calculate the vertical stack pipe. As you can see over here, this is represented by J. So when you are calculating the vertical stack pipe size, you need to sum up all these branches fixture unit load, that is 70, 90, 120 and 90. That is equal to 370 fixture units. So 370 fixture units load will be on this vertical stack represented by J. Now to calculate the vertical stack pipe size, you need to use this table 6-3, that is maximum permissible fixed unit load for sanitary stacks. So this first column is for the, if we have a 3-story building or less than 3-story building, then we have to use this column. If you have more than 3-story building, then you have to use this third column. Since we have a 9-story building, so we are going to use this third column. So since we have 370 fixture units connected to this vertical stack J, so 370, these are the fixture unit values. 370 fixture unit, that means it is between 60 and 500. So obviously we'll go for the higher value, 500. So if you move to the left side, you will find the stack diameter is 4 inches to the 500 fixture unit value. But you need to check one more thing in the last column, that is total discharge in each branch interval fixture unit is 90. This condition should be satisfied, that total discharge in one branch interval should not exceed 90 fixture unit value. But if you go there, you find that this 70 is okay, 90 is okay, 90 is okay, but here we have 120 fixture unit value. So these branches connected to the stack J is not satisfying the condition of 90 fixture unit value. So this is exceeding with one branch interval. This branch has more than 90 fixture unit value, so we cannot take this value for 4-inch pipe size. So we need to increase the pipe size from 4 to 5 inches. So if you select this 5-inch pipe size, you can see in the last column we have total discharge in one branch interval is 200 fixture units. Since 200 fixture unit is the maximum in each branch interval, if you see over here, we have all branch interval less than 200, that is 70, 90, 120 and 90. So our condition is satisfied, so we can select this 5-inch pipe size for this vertical stack J. So this is 5 inches. And then we have to calculate this offset runout pipe size, and the slope which we used in our project is 1/8 inches per feet. So this K section or runout or offset is going to be sized based on the table 6-5, maximum permissible fixture unit load for sanitary building drains and runout from the stack. So this is a runout from the stack pipe, or it is also called offset. So how many fixture unit we have here? Same A, B, C, D, you need to sum up all these branches, that is 370 fixture unit over here. So 370 fixture unit with 1/8 inch slope, so 370 fixture units, it is in between 180 and 390. We'll go for the higher value, 390. So for 390 with 1/8 inch slope, you will find 5-inch pipe diameter. Even if you are using 1/4 inch slope, it will also be 370 will also be in between 216 and 480. Obviously we'll go for the higher value, 480. So same 5-inch pipe size. So since we have 1/8, so 5-inch pipe size we are going to use in here for this offset K. And then we have this vertical stack again representing by L. So here if you are calculating the pipe size for this vertical stack L, it will be the sum of all the fixture unit above offset and all the fixture unit below offset. This is the offset, sum of branches above offset, sum of branches below offset, to get the size of this stack L. So we know that 370 here, and how much is here you can calculate, that is 370 plus branch E is 150, F is 180 and G is 190, H is 160 and I is 200. So total fixture unit value to calculate the size of this stack L is 1250 fixture unit. So as I told you, to calculate the stack pipe size, we have to use this 6-3 table. Total fixture unit value for more than 3 story stack, more than 3 stories, we have to use this column because we have a 9-story building. So we have total fixture unit value is 1250. 1250 is in between 1100 and 1900. So obviously we'll go for the higher value, so we'll go for 1900. So for 1900 you can see that 6-inch pipe size. Same time we have to check the total discharge in one branch interval is 300 fixture unit. So each branch interval should not exceed 300 fixture unit value. So let's check and verify the condition. So maximum fixture unit in each branch interval is 200. So it is satisfied, this condition is satisfied that our each branch interval, that is total discharge in our each branch interval, is less than 350 fixture unit. We have a maximum of 200 fixture unit. So this condition is satisfied, so we can use easily this 6-inch pipe size for vertical stack L. And in the end we have to calculate this pipe size for this offset or runout represented by M. So total fixture unit value, it will be the sum of all branches from top to the bottom. We already know that is 1250 fixture unit. So this is runout or offset. As I told you that we have to use table 6-5 to calculate this offset pipe size that is going directly to the manhole, and total fixture unit value is 1250 and slope which we used is 1/8 inches. So 1250 is in between 700 and 1600. So obviously we go for the higher value 1600. So 1600 you can find the pipe diameter, that is 8 inches. So we can use 8-inch pipe size. Again, if you note over here that 1250 is coming in between them, so we'll go for 1920. If you have a slope of 1/4 inches, still pipe size will be 8 inches. So since in our project we use 1/8 inches, so it's the same, that is 8-inch pipe diameter. That value is coming between 700 and 1600, and our fixture unit value is 1250. So we are going to use 1600 and pipe diameter is 8 inches. So M is 8 inches. So this is how you can calculate your drainage pipe size by using the tables from ASPE, American Society of Plumbing Engineers, IPC and UPC, that is Uniform Plumbing Code. But again, I have to tell you one thing, that you have to follow the local codes of your area. For example, if you are working in India, you have to get the values from the local authorities. These tables you have to get from the local authorities, because every region has its own codes and standards developed by them. For example, if you're working in the Gulf region like UAE and Saudi Arabia, Bahrain, Qatar, you have to follow their standards. This is an international standard which I have discussed in here. So I hope you guys learned something from this video. The topic which I'm going to discuss today is related to the drainage vent pipe sizing. So there I have an Excel sheet, as you can see here, and these are the tables which I'm going to use for drainage vent pipe sizing. So I'm going to discuss two examples here. This is the first example and this is the second example. So in the first example you can see that we have individual vent pipes which will do the sizing, and in the second example, this is the second example, you can see here if you see that we have the vent stacks, that is A, B, C and D, that are connected to the common vent header. This is our common vent header at the top of the vent stacks, and then extended through the roof at one point. So this is the second example. So in first example, if you have noticed that this is the same example which I had used during the drainage soil stack pipe sizing. If you have not seen that video, I will give the link in the description below. You can watch it, because this vent stack pipe size is related to the soil stack pipe size, so you must watch that video. And if you see that here we have vent stack that is represented by section B. Vent stack is represented by section B, and you can see that this is the dashed line representing the vent pipe, and this is our soil stack is represented by A. So this is our second vent pipe, you can see here, represented by F in the dash lines, and this E is basically representing the soil stack. So when you are doing the vent pipe sizing, three things should be known. First is the soil stack pipe size, second is the drainage fixture units connected to that soil stack pipe, and third is the developed length. So these three things should be known before doing the vent pipe size calculation, or before getting the vent pipe size. So what is developed length in here? So you need to understand the developed length first. So developed length is basically the length of the vent stack is measured from the point of connection to the drainage system at its base point. So this is the base point from here to the point of discharge at the outlet above roof. So from the base point of the drainage system to the point of discharge at the roof level. So this is our high roof level, and this is our low roof level. Six story, you can see that we have a low roof level in here. So from this base point of the drainage system to the top of the roof level, this is representing the developed length. Before starting the vent pipe sizing, there is one announcement about the channel membership. If you join my channel membership, you can get access to all Excel sheets, relevant softwares, and carrier air conditioning design handbook. So basically the membership on my channel has 3 levels. Membership link I will give in the video description, or you can go to my channel and click the join button. So let's start the pipe sizing with the first example. So this is for the first example. You can see that the section B here, as I said, that vent stack is represented by section B. So I said that three things should be known to get the vent pipe size. So first is you have to check the soil stack pipe size. So I'm not gonna discuss the soil stack pipe size, how did we get this one. So for that purpose you should go for drainage system design or drainage pipe sizing video. I will give the link in the description below just to save the time. So I will proceed to the next step, that the connected drainage fixture units. So you can see that total connected drainage fixture units is how much: 90, 70, 120 and 50. So we have total 4 branches here, that is 90, 70, 120 and 50, total 330. So up till this point we have 330 fixture units connected here. So we write here 330 fixture units, and the developed length, which I said that from the base point, so we are talking about this vent pipe. So developed length is from the base point to the top of the roof level. So you can see that 10 feet, 10, 20, 30, 40, 50 and 55. So developed length is 55 here. So now we have to check the vent pipe size here. How much is the vent pipe size connected to the vent stack connected to the soil stack having size 5 inches. So we know that soil stack pipe size is 5 inches. Developed length is 55 and connected drainage fixture units are 330. So we're gonna use this table 9-1. We said that soil stack pipe size is 5 inches and 330 fixture units. So 330 fixture units is in between 200 and 500. So we'll go for 500 higher value. And so before going this about this table, these pipe sizes 1/4, 1/2, 2 inches, these are basically vent pipe sizes, These are the connected drainage fixture units, and this is the soil stack pipe size, and in between we have these develop lengths. These are the develop lengths. So we know that 5-inch pipe size, soil stack pipe size, and 330 fixture unit will go for 500, and develop length is how much? 55. So 55 is in between 30 and 70, will go for higher value 70. So 70 you will check the pipe size is 3 inches. So vent stack pipe size is 3 inches. So we got 3-inch pipe size in here. So same way you have to check for the second one. That is second stack pipe is represented by F. You can see in here. So how many branches are connected to this stack F? So we need to include the branches above this run out. We need to add this one also. So 330 plus 160 plus 200 plus 230, and the last one is 170. So total drainage fixture units connected are 1090. 1090 we can write here. So again we have to check the develop length. How much is the develop length? Since this one is connected from the base point of the drainage system to the top of the roof level, this is onto the low roof level. So total develop length is 10 feet, 20, 30, 40, 50 and 55. So again 55 develop length here, and 1090 drainage fixture units. And again you have to check the connected soil stack pipe size. You can get that one if you see the video, drainage pipe sizing video. So we use the table 9-1 again. 1090 drainage fixture units, and soil stack pipe size is 6 inches and 55 is the developed length. So 6 inches with 1090 drainage fixture units, 6 inches and 1090 drainage fixture units. 1090 is between 960 and 1900, so we'll go for 1900. And develop length is 55, again between 20 and 70, we'll go for 70. Higher value, there is no 55, so we'll go for 70 and check the pipe size is 4 inches. Vent stack pipe size is 4 inches, so we have right 4 inches here. So now I'm going to discuss the second example here. Here you can see that we have 4 vent stacks represented by A, B, C and D. These are connected to the common vent header. This is a common vent header and then extended to the roof. So we'll start from stack A. You can see here I have divided into different sections. Stack A, you can see that fixture units are 150 and develop length is 180. So 150 fixture units, 180 develop length. So we need to check the soil stack pipe size. So soil stack pipe size, and then we have to check the vent stack pipe size, and then we will check the header pipe size later. So first we check for the stack A, soil stack pipe size and vent stack pipe size for this section A. So first check the soil stack pipe size using the table 6-3. So we have 150 fixture units. 150 fixture units. Since we know that we have more than 3 story, so 150 fixture unit, we have to use this column. 150 is in between 60 and 500, so we'll go for 500 higher value, and we'll check the soil stack pipe size is 4 inches. So 4 inch. So now we have to check the vent stack pipe size. So we know that developed length is 180 feet, and we know that soil stack pipe size is 4 inches, and we know that drainage fixture unit connected are 150. So we use this table 9-1. So 180, 150 fixture units, 180 developed length. 150 fixture units, 4 inch pipe size. 150 fixture units, 100 and 200 is here, so we'll go for 200. And develop length is 180, is in between 90 and 250, so we'll go for the higher value 250 and check the vent pipe size is 3 inches. So vent pipe size is 3 inches. So next is A to B. This is the vent header section A to B. So here we will check the header pipe size now. The developed length is now 180 plus 10 more, that is 190. So developed length is 190, 180 plus 10. This is the 10 feet. Drainage fixture units connected are same, that is 150, same. So 150 fixture units and 190 developed length. So 150 is, again we check the size for the soil stack is again 4 inches. So 4-inch pipe size and 150 fixture units and 190 developed length. 150 fixture units is in between 100 and 200, and 180 is the developed length is in between 190 is the developed length is between 90 and 250. You'll go for 250. Again pipe size is 3 inches. So header vent pipe size is 3 inches. Section A to B header pipe size is 3 inches vent pipe size. So now we'll go for stack B. 200 fixture units, 290 developed length. 200 fixture units, 290 developed length. Now we'll check for soil stack pipe size and vent stack pipe size. So 200 drainage fixture units. First check the soil stack pipe by using the table 6-3. So again, more than 3-story, 200 fixture unit is in between 60 and 500. So we'll go for higher value 500 and check the pipe size is 4 inches. So pipe size soil stack is 4 inches. Now check for the vent stack pipe size. So we know the soil stack pipe size is 4 inches. We know drainage fixture unit 200 and 290 is the developed length. Now we check the vent stack pipe size. So again we use table 9-1. So 4 inches, 200 fixture units and 290 developed length. So 290 developed length is in between 250 and 900. So we'll go for higher value 900 and check the vent pipe size is 4 inches. So this stack B vent pipe size will be 4 inches, this vent pipe. And then we'll go for header pipe size B to C. Now we'll check for header pipe size B to C, this one. So we know that the drainage fixture unit A to B is 150 and this stack B is 200. So 150 plus 200, it will be 350 for the point B to C. So you can see here 150 plus 200, that is 350 drainage fixture units. So now the developed length we can see here at point A to B, total developed length was 180 plus 10, that is 190 plus 40. 190 plus 40, that is 230. You can see here 190 plus 40, that is 230. So now we check the header pipe size B to C. So we know that drainage fixture unit 350. So first check the soil stack pipe size, how much it would be. So based on this we have to check header pipe size. So 350 if we check the, so again in between this, and we'll go for higher value 500, 4 inches pipe size. So 4 inches we have to check developed length 230 and 350 fixture units. 4 inches, 350 fixture units is in between them, so we'll go for the higher value 500, and developed length is 230. 230 is between 180 and 700. We'll go for higher value 700 and check the vent pipe size is 4 inches. So the header vent pipe size B to C is 4 inches. So now I'm gonna skip B to C, C to D. B to C is already done, so I'm gonna skip C to D and stack C just to save the time. So I'll go for the last one, stack D, 500 fixture units and 270 developed length. So 500 fixture units at stack D and 270 developed length. First check the soil stack pipe size for 500 fixture units. So again 6-3 table, 500 fixture units, soil stack pipe size is 4 inches. 4 inches. Okay, and then we know that developed length is 270. You can see that here, developed length 270. So soil stack pipe size is 4 inches, 270 developed length, and 500 fixture units. So 4 inches, 500 fixture units, and 270 developed length is in between 180 and 700. We'll go for high value 700 and check the vent stack pipe size is 4 inches. That is 4 inches, you can see here. So now the last one is from D to the outlet. You can see that from D to this is the roof level extended up to the roof. So for total developed length will be how much? That is C to D. C to D it was 260. C to D it was 260 plus 40 plus 10. So 260 plus 40 plus 10, that is 310 total developed length. And fixture units, if you see that here 500 fixture units, here you can see that C to D fixture unit which we calculated is 550. So 550 plus 500, it will be 1050 fixture units. So we know that developed length, we know that drainage fixture units, so we can calculate the vent header pipe size. So first check the soil stack pipe size, how much it would be on 1050 fixture units using table 6-3. So 1050 fixture unit is in between 500 and 1100. So this value 1100 we will take. So soil stack pipe size will be 5 inches. So 5 inches with 1050 drainage fixture units and 310 developed lengths. Let's check the header pipe size, vent header pipe size. So 5 inches 1050, that is equal to almost 1100. So 5 inches soil stack pipe size, 1100 drainage fixture units, and developed length is 310. 310. So 310 is in between 200 and 700. So you will go for the higher value 700 and check the vent header pipe size is 5 inches. 5 inches. So you can see that this is the 5 inches. So this is how you can do the drainage vent pipe sizing. If you have the individual vents, or you have the vents that is connected to the common vent header. The topic which I'm going to discuss today is related to the total water supply demand calculation for a building. If you remember, about 1 month ago I made a video related to hot water and cold water pipe sizing. In that video I did not explain how you can calculate the water supply demand. So in this video I'm going to show you how you can do that by using a water supply fixture unit method, that is WSFU, and by using International Plumbing Code IPC and UPC, that is Uniform Plumbing Code. But before proceeding towards the calculation, I want to tell you one more thing. In my next video I'm gonna discuss about the water distribution pipe sizing with one more complicated example. As you can see that we have risers in here also. In the previous example for water supply and hot water and cold water pipe sizing, it was not complicated. So in my next video I'm gonna use this complicated example. You can see the risers are also included in here, so you will learn more in this video. And we're gonna do the pipe sizing for the main service lines, and we're gonna do for water supply distribution piping, and we're gonna go for risers also. So let's move back to our main topic. So let's say we have an office building, and we have a number of fixtures are described in here. Like water closet, we have flush type, and 60 water closets are in there. And urinals, we have a wall hung type, and a flush valve type is used in there. So 12 urinals, and lavatory we have 40. So it depends on number of fixtures which you have in your drawing. You have to write the total number of fixtures in here. So second thing, you have to, since we are using water supply fixture unit method, so we have to write the fixture unit value associated with each fixture. So here are the tables and charts which I'm gonna use. So first fixture is water closet and number of fixtures are 60. So there is no hot water required for this one, so we'll go for cold water fixture units and total water fixture units. So if you see over here, and the occupancy is also matter, since this is an office building, so we're gonna select this public space instead of this private space. And type of supply, we know that this is a flush valve instead of flush tank. So water closet, public type, flush valve. You see the cold water fixture unit required are 10 and total water supply fixture units are also 10. So move back here to our Excel sheet and write cold water fixture units are 10 and combined water supply fixture units are also 10. So since we know that one fixture unit requires 10, so 60 fixture unit you need to multiply 60 into 10, that is 600. Again same thing, 60 fixture units in here and combined water supply fixture unit value is 10, so 600 is the total water supply fixture unit. And urinals we have 12. This is a wall hung flush valve type. Move back to our chart and tables. So here you can find stall or wall urinals and stall or wall urinals, one with the flush valve, another with the flush tank. So since we have used the flush valve type, so we are gonna use this value. So cold water required is 5 fixture units and total is also 5. So same way we have to write cold 5 and total is also 5. Again you need to multiply this number of fixture with cold water fixture unit to get the total water supply fixture unit here for cold water, and total water supply fixture units are also 5 by 12, that is 60. And the last fixture we have here is the lavatory, and lavatory required both hot and cold water. So move back to our tables and charts and find the lavatory in here, and you can see that this lavatory is private and we are looking for public. So you can see that this is lavatory. Since we have an office building, that's why I'm going to use public occupancy. So lavatory, public, faucet type, you can see the hot water fixture unit is 1.5, cold is also 1.5, and total fixture unit required are 2. So hot and cold are 1.5 and total are 2. So we can write hot water fixture units are 1.5 and cold water is also 1.5 and total 2. So simply you need to multiply this fixture unit with number of fixtures, this fixture unit with number of fixtures, and this fixture unit with number of fixtures to get this total cold water fixture unit, total water supply fixture units, and total hot water fixture units. So this is the demand which we calculated here is the intermittent demand, that is a non-continuous demand. It's not used all the times, its frequency of use is different, it's not used as continuous demand. This is a non-continuous demand. We need to add the continuous demand to the non-continuous demand if continuous demand is available, but before that we need to convert our fixture unit values into the GPM. So since we know that total hot water fixture unit is 60, so we have write 60 in here, and total cold water fixture unit, it is a sum of these three, that is 720 fixture units, and combined water supply fixture unit we have in here is 740 fixture units, that is the sum of this one. Now we have to convert this fixture unit value into GPM, so we are gonna use the table in here. So this is the table, you can use this chart as well as this table to convert this fixture unit to equivalent GPM. So first is a hot water, that is 60 fixture units. So hot water 60 fixture units for the lavatory. So we are gonna use this there we have two columns, flush tanks and flush valves. So we have 60 fixture unit. For flush tank it's 32 GPM. 60 fixture unit is 32 GPM. So we're gonna write 32 GPM in here, and then we have to get the value for cold water fixture unit and combined fixture units value also. So total water supply fixture unit are 720 in here, so we have to go back. But cold water, if you see that we have a flush valve type for this one, so we are going to use flush valve column in here. Whatever the valve you are using in there, you have to follow that column. So 720 fixture units. So we don't have 720, we have 500 and 750. So if you go for the second column, this is flush valve, so we have 720, so I'm gonna write approximate value in here, that is 100. Let's say we are gonna write 174 value in between them, and we check for total water supply fixture unit value or combined water supply fixture unit is 740. So 740, if you go in there and let's say approximate value, we will get between 500 and 750 is fixed. Let's say we get the GPM of 177 GPM. You can do interpolation to get the exact value. So right now I'm just writing the approximate value, that is 177 GPM. So this is our intermittent demand which we calculated in here. So now we have to add this demand with the continuous demand. If you have any continuous demand, you have to add this with intermittent demand. So let's say we have 2 hose babes there, and we have to go back to our tables and chart to get the fixture unit value for this hose babe. So as you can see that demand at individual fixtures and required pressure. If you see, this one is the flow rate GPM, this is the fixture, and this is the pressure. So this is the hose babe as you can see over here, and the GPM required is 5 GPM. So we have 5 GPM required in here. So 2 hose babes, it will be 10 GPM. And the second continuous demand is air conditioning makeup water. So this value you have to get from the HVAC design engineer. So how much is the required GPM for the air conditioning water makeup? So let's say we get this value 30 GPM. So we just need to add these two values to get the total continuous demand. So TCD is the total continuous demand, that is 10 plus 30 equal to 40 GPM. And then you can see that hot water demand, here hot water demand we already calculated, that is 32 GPM in here. And the cold water demand, you need to add this continuous demand also in the cold water demand, because this water supplied here for the continuous demand is also normal or cold water. There is no hot water required in here. That's why we did not add any continuous demand to our hot water demand. It's simply 32 GPM. But for cold water demand, we need to add this continuous demand also, because this also required normal or cold water, hose babes and air conditioning water makeup equipments. So total cold water demand will be, that is cold water demand we calculated here 174, for intermediate demand, and continuous is 40. So 174 plus 40 equal to 214 GPM. And total water demand required here is 217, that is 177 is the total water demand here, plus continuous demand, that is 40. So total water demand required is 217 GPM. So reason why we have calculated hot water demand, cold water demand and total water demand, because if you move back to over this example which we are going to discuss in the next video. So here if you see, this is our service main. So we are gonna this service main pipe sizing based on our total water demand required. So we have to do sizing based on total water supply demand required, that is this value. So if you go from here, from this is our pump, that is a booster pump, this is the suction, and this is the discharge. So from service main to the point of connection to the, this is our hot water heater, from service main to the point of connection to the hot water heater, we have to do the sizing of this water supply piping based on this GPM. This is just an example to show you that that's why we have calculated this total water supply demand. But after that you have this hot water piping in here, so you have to do this hot water piping based on this hot water demand, because here you have hot water supply, this is hot water supply, and then this is your cold water supply. After this point of connection you have this cold water supply, so you have to do the sizing of this cold water supply piping based on this cold water demand. That's why we have calculated this hot water demand, cold water demand, and total water demand. So I hope you guys learned something from this video. For more videos, keep watching my channel and don't forget to subscribe and don't forget to press the bell icon. Thank you.